Okay, I'm making a recording of class from Friday, our Friday material. The bell is going to ring as I'm going through this, so please persevere and don't get distracted by that. I might pause it. This is the warm-up we did in class to start. I'm solving these x squared problems. When I have a square by itself, I square root both sides. When I square root both sides, it's going to give me x equals plus or minus something. I don't actually remember what it was, so I'm going to grab my calculator and do it on my calculator real quick. Square root is 18 is 4.24. I've yelled at many of you many times for not doing the plus or minus. Remember your plus or minus is 4.24. On problem 2, when I'm solving this, when you're solving, do the order of operations backwards. Do SADMAP. So I want to get rid of the 4 first. And that gives me 2 times x minus 1 squared equals 8. And I divide everything by 2, which gives me x minus 1 squared equals 4. Now that I have a square by itself, I have something being squared, even though there's more than a variable in there, even though there's a parenthesis with an x minus 1, I can still square root both sides to kill off that square. And that gives me x minus 1 equals plus or minus 2. And now this is just like an absolute value problem. Remember we got something like this when we did absolute value? We'd make two equations, a positive one and a negative one. Well here, I have a positive and a negative equation again. So I'm just going to make a positive equation and a negative equation and solve both of them. X minus 1 equals 2, x minus 1 equals negative 2. So x equals 3 and x equals negative 1. You might be asking, well, could I have distributed this 2 in here first? You can't distribute the 2 first. If you distribute the 2, you're doing simplifying. And when you're simplifying, that's when you do PEMDAS. And there's an exponent in this problem. Because of the exponent, you have to deal with the exponent first when you're simplifying. So if you get around that, we don't bother simplifying at all. We just solve. And solving is when you SADMAP. I will talk more about that on the next screen. Problem 3, add a 20, and I get negative 4x squared equals 54. Divide both sides by negative 4, and I don't even care what x squared over 54, what 54 over negative 4 is. I don't even care what that is, because what I care about is that it's a negative number. And since it's negative, I can't square root both sides, because I can't square root a negative. So this has no real solution. You could have worked out that 54 over 4 was 26.2, no. What is that? 16.25, 12.13.25, 13.5, I don't even know. I think it's negative 13.5. The point is it has no real solutions because you can't divide by a negative number. Okay, I'm going to take the same problem 2. I'm going to take this problem 2 and copy it on the next page. Now, a couple people asked me in both classes, well, couldn't I do the squaring first? Even though I can't distribute the 2 first, can I square first? That would give me this. That's our special products that we've talked about. So take my word for it if you don't believe me. Then I would distribute the 2, and I'd have 2x squared minus 4x plus 2 equals 12. So that's 2x squared minus 4x, plus 4 there, plus 6 equals 12. So the real question that we have now is how do we solve this? How do we solve 2x squared minus 4x plus 6 equals 12? I'm going to write it over here. 2x squared minus 4x plus 6 equals 12. I could go through all the methods that we tried in class on Friday, and we tried a lot of them. Let's see if this works. No, that didn't work. We tried a lot of them. We tried like subtracting 6 from both sides. Excuse me, I apologize. Let's make this black. Let's get a new pen. Let's make that new pen orange. We tried like subtracting 6 from both sides, so we had 2x squared minus 4x equals 6. And we divided everything by 2 to get x squared minus 2x equals 3. And we still have two x's over here. There's an x here and there's an x here, and they can't go together. I can't add them or subtract them because they're not like terms because of that power. So we can add x squared or add 2x to both sides. And we can't square root because I don't know how to square root 3 plus 2x. When there's a plus in there, I can't do a square root. We tried all kinds of things and nothing works. And the reason that nothing works is because we have two variables. This is the first time we've ever had two variables. Back in our warm-up, one variable, one variable, one variable. We could do it. In fact, when we've had two variables, it's usually been something like this. And we could simplify, and we could combine our like terms and do it from there. But we can't combine these like terms because one's squared and one isn't. So we need some new methods for solving. Our old algebra methods don't work. When we have an equation with both an x squared and an x, our regular old algebra methods don't work anymore. We need new methods. The first new method we learn is called factoring. And that's what chapter 8 is. Chapter 8 is on factoring. Factoring is quite literally one of the most important skills you're going to learn in this class. Oh wait. Man, these bells take forever. You need to be able to factor. We're going to spend a ton of time in this class on factoring. Factoring is just like doing the distributive property backwards. So here's a regular distributive property, where I have 3x times x is 3x squared, and 3x times 4 is 12x.
Good afternoon.
Good afternoon, everybody.
Happy Friday.
Happy Friday. Happy Valentine's Day.
Remember?
I'm going to pause. Okay, we're back. The announcements took like 7 hours. I was distributing. This distributes and gives me this, and we call that distributing, and from now on I'm going to call it expanding. We're making something smaller and making it a little bigger. Well, the opposite is called factoring. I take an expanded expression and I see what do they both have in common. They both can be divided by 3x. So I divide out that 3x and I get 3x times x plus 4, and we've just taken, ooh, this will be fun, we've just taken this process here and we've done it backwards. Same, just flipped. Okay. So I'm going to pull out greatest common factors from all of these expressions. Right now they're in expanded form. I'm going to pull out greatest common factors and get them into the factor form. In this first expression, the greatest common factor they all have in common is 4. I can pull a 4 out of this, a 4 out of this, and a 4 out of this. So when I pull out a 4, I'm doing 4x squared divided by 4, which is x squared, 12x divided by 4, which is 3x, and negative 8 divided by 4, which is negative 2. And that is my factored form. Oops, that big fancy there.
Maddie Mark, Green Stoll, and Abby Allman, please come to the front office. Maddie Mark.
Hey, what can I do for you?
Hi, Mr. Gilchrist.
What's up?
I just wanted to say I'm sorry if I was rude about my phone today in class.
Sorry, what was that?
I said I wanted to say I'm sorry if I was rude when you were talking to me about my phone today in class.
Yeah, because you had your phone out during a test.
Yeah,
and you should never do that.
Yeah, I won't do that
Yeah.
again. I just want to apologize.
I appreciate you apologizing. Anything else you'd like to say right now?
I was actually going to ask you, we talked yesterday, since you were grading the second quiz.
Yeah, I haven't looked at it yet. I might.
What?
I might look at it. Anything else?
Okay, that's
Okay. What's your favorite color?
green.
Why?
I don't know, because it's a good color.
Okay. Who's your favorite freshman boy?
I don't know why.
I'm recording all this.
What?
So I was just curious about these things. I'm doing a lesson right now. Okay. See ya. This is a very rude interruption. I apologize for Sarah. That was just a very rude thing Sarah just did. I'm going to factor this. What do they have in common? Well, I can pull out a 2, and I can pull out an A. They all have an A in them, so I pull out 2A. When I pull out 2A, I have 2A to the 5th divided by 2A, which is 4A to the 4th. Let me explain what I did there. I did 8a to the 5th, was what I started with, 8a to the 5th. It's being divided by 2a. So that's 4a to the 4th, just like we did in our last test. So if I do 12a to the negative 12a to the 4th divided by 2a, that gives me negative 6a to the 3rd. And if I do positive 10a divided by 2a, that's just a positive 5. You'll note that all of the x powers drop by 1. Hello, Mitchell. How are you?
Good. So on Tuesday, I have a seal feed.
Interruptions. You'll notice that all of these powers drop by 1, drop by 1, drop by 1, drop by 1, because we pulled out 1a. It went from a to the 5th to a to the 4th. It went from a to the 4th to a to the 3rd. It went from a to the 1st to no a's at all. The problem with these markings is eventually you can't tell what's going on. Okay, next problem. What do these have in common? You should pause it and take a second and do it on your own. So you can factor this on your own before I do it. Okay, I'm going to factor it now. They all have a 3x squared in common. They all have at least an x squared in them. So I'm going to pull out 3x squared, and I'm left with 2x to the 3rd minus 4x plus 3. Next, when your leading coefficient is negative, if your leading coefficient is negative, pull out a negative number. Since I start with a negative 2, I'm going to pull out a negative 2. Not a positive, but a negative. So I get 2x to the 4th minus 5x to the 3rd plus 9x minus 5. You'll notice that all the signs switched from the first problem to the last one. And finally, I'm going to pull out, again, pause and try it on your own if you'd like to. I can pull out a negative 4xy. What these have in common is a negative 4xy. So let's see what happens. I pull that out, and I get positive 2x squared y minus, oh, they have a 4 in common. They have a 2 in common. All I can pull out of these is a 2. I think I meant for that to be like a 16 right there. Oh well, that was weird. So I'm going to pull out a 2. Pull out a negative 2xy and I get 4x squared y. Pull out a negative 2xy from here, and I get negative 3xy. Pull out a negative 2xy from here, and I get 2x. Pull out a negative 2xy from here, and I get just a 4. The xy's are all gone. Beautiful. Any questions? Sorry, I can't answer them. This is just a video. Factor by grouping. Whenever you have 4 terms, whenever you have a quadnomial, you should try to factor by grouping. Factoring by grouping is like pulling out the GCF twice. We're going to do what we did over here twice. The first thing I do is I slash it right in the middle. And I make sure that this sign right here, that plus, is with the stuff after it. I pull a GCF out of these. These both have a 3a in common. When I pull out a 3a, I'm left with a minus 2. Over here, these have a 6b in common. These have a 6b in common, and it's positive, so I'm going to pull out a positive 6b. And I'm left with another.
Julia Hastings, you have a pickup in the front office. Julia Hastings to the front office.
Well, these two bubbles, I'm going to call these parentheses bubbles from here on out. These two bubbles are the same, which means that I can take these things in front of the bubbles and make one bubble out of them. 3a plus 6b combines into one bubble. And then these two kind of form as one. You don't multiply them or add them or anything, you just sort of copy it down again, a minus 2. And this is factored. If I were to FOIL this, if I wanted to check, I could FOIL this, and I would get what I started with. That's how you can check your factors always, but I'm not going to do that right now because that would be confusing. So, again, if you want to try it on your own, go ahead. Cut it in half. I can pull out a 2x, and I have 2x minus 5. I can pull out a negative, because that negative there, I pull out a negative 3, and I'm left with 2x minus 5. So this factors into 2x minus 3 times 2x minus 5. Next, I'm gonna slash it. I can pull a 2x out of these, and I'm left with y minus 1. These two don't seem to have anything in common. And so what I'm going to do is sort of weird, but I'm going to pull something out. So I pull out -1, because the leading coefficient here was -1. So I'm going to pull that out. That gives me y minus 1. This sign changes because I pulled out a negative. So it becomes 2x minus 1 times y minus 1. Beautiful. We've been doing all this factoring so we can start to solve some things.
Yeah. If Bree, Sorrel, Maddie, Art,
Remember, we talked about needing to solve problems like this. We talked in class about how if a times b is 0, we know that either one of these is true. Either a equals 0 or b equals 0. One of those two things must be true. It's possible they both equal 0, but that's not necessary. It's just possible. But this isn't true if, like, a times b equals 12. If a times b equals 12, I don't know anything about a and b, because a could be 2 and 6, or it could be 3 and 4, or it could be -12 and -1, or it could be 1/2 and 24. I don't know hardly anything about a and b. So this factoring method only works if you're equal to 0, because that tells us that one of the two factors, one of the two bubbles, must be equal to 0. And that's very useful. If I have an equation like this, 2x squared plus 4x equals 0. If I pull out the GCF, the greatest common factor of these two things here is 2x. I can pull out a 2x, and I'm left with x plus 2. What's like, from way up here, from this stuff up here, it's like this is my a, and this is my b. So I know that at any time, one of these two things is going to be equal to 0. So I can figure that if x equals 0, or if x equals -2, I can plug either of these things in for both x's above and get my solution. Let me show you what I mean. If I take x equals -2, and I plug it in for both x's, that becomes 2 times -2 times -2 plus 2, which is 2 times -2 times 0, which is 0, which is what I wanted. I wanted to get out 0. If I plug in a 0, I get 2 times 0 times 0 plus 2, which is obviously 0, which is also what I wanted. Remember, all of these problems have two solutions. That's why we have plus or minuses and everything. Plus or minus means there's two solutions. 1, 2. This had no real solutions, but there was potential for two solutions. So you're always looking for those two solutions. That's what factoring lets you do. Factoring lets you find those two solutions. So let me do some more examples. I'm going to solve this equation up here by factoring. So if I factor out a 4x, I'm left with x minus 3. And this all equals 0. Well, then I know that x is either going to be 0 or x is going to be equal to 3. And I'll explain how I know that now. I can take, remember these are kind of like bubbles, like that's my a and that's my b. I can take the bubbles and set them equal to 0 and solve. If I take x minus 3 and set it equal to 0 and I add a 3 to both sides, well, that means that x equals 3. That's one of my solutions. If I plug a 3 in for x, I get 4 times 9, which is 36, minus 36, and that's 0. Do another one. Factor out a 2x, and I'm left with 3x plus 1. Well, obviously for this, one of my solutions is 0. You can kind of see that in the original problem. If x is 0, the whole thing becomes 0. For my other solution, I'm going to take 3x plus 1. I take whatever's inside this bubble, set it equal to 0, and solve. I subtracted 1 and divided by 3. There's my other solution. X is 0, or x is -1/3. Next problem, I have 4 terms. When there's 4 terms, I group. So I'm going to split this in half. I can pull a 5x out of this, and I'm left with x plus 3. I can pull an 8 out of this, and I'm left with x plus 3. And that'll equal 0. So I have 5x plus 8 times x plus 3 equals 0. If I take those two bubbles and set them equal to 0, if 5x plus 8 equals 0, then 5x equals negative 8, and x equals negative 8 over 5. That's one of my solutions. Now I'm going to grab the other one. If I take x plus 3 and set it equal to 0, then x equals negative 3. That's my other solution. If you wanted to plug them in and check, you could. They would work. Beautiful. Last one, then we're done, I think. Cut it in half. I can pull a 2x out of these, and I'm left with x minus 4. I can pull a negative 6 out of this half over here, and I'm left with x minus 4. So I have 2x minus 6 times x minus 4, and that'll equal 0, which means that x could either be 4, or it could be 3. X could be 4, or x could be 3. I can plug them in and check. Take my word for it, they work. I think that covers everything. It does. Hopefully that helps you with your homework. If you have any questions, feel free to email me, or even if you wanted to, you can make a video response to this and get back to me. I should probably just leave that thing here, so I'm probably driving me crazy at this point looking over this. Just make sure it all looks good. There's where I ended. Have a wonderful weekend. I will see you on Wednesday, of all things.